All right, I want to take a look at this other section of notes for this week, just talking about properties of logarithms. There's a couple of big things in here that you'll have to do quite a bit, really working with logarithms, and I'll get that here in a little bit. But here to start, we're going to talk about just some properties of exponents that we had last unit. So just remember that when you are multiplying two things together with the same base, you add the exponents. And when you are dividing two things with the same base, you're going to subtract the exponents. Logarithms have similar properties as well. If we look here at these two examples, log base 3 of 9 plus log base 3 of 3. If I were to rewrite that, 3 to what power is equal to 9? That would be 2. 3 to what power would be equal to 3? That would be 1. So those two logarithms simplify down to just 2 plus 1, which is equal to 3. And if I look at this one over here, log base 3 of 27 is equal to 3 because 3 to the third power is equal to 27. You notice there those two answers, 3 is equal to 3. And you probably notice as well that if I took these two arguments, the 9 and the 3, there's one simple operation that I would have to do with multiplication to get it to equal this argument as well. If I look at this problem, log base 2 of 32 minus log base 2 of 4, and compare that to log base 2 of 8. Log base 2 of 32, if I were to rewrite that, 2 to the fifth power would be 32. And then this one, log base 2 of 4, 2 squared would equal 4. So we end up with, again, 5 minus 2 is equal to 3. And then 2 to the third power is equal to 8. So if I compare these two arguments and right here, 8, what could we do to go from 32 and 4 down to 8? And that would be to divide those two arguments. So jumping down here into the properties of logarithms that we're going to be working with. The first one, and I like how they kind of rewrite this in words, because I think sometimes we have symbols, but when we write it out in words, it kind of makes a little bit more sense. So log base b of m plus log base b of n is the same thing as log base b of m times n. So if you have two logarithms with the same base and you are adding them, you are able to simplify them by rewriting it as a single logarithm with the same base, but we are going to take the two arguments and multiply them. And the same thing is true with the natural logarithm, or really the common logarithm as well. The second property, if I have log base b of m minus log base b of n, we are going to divide the two arguments, and the same thing is true with natural logarithms. So when two logs of the same base are subtracted, the result is a single log of the same base whose argument is the quotient of the original arguments. Third property, log base b of b to the n power is equal to n, which makes sense because if you were to rewrite this, there's my base, b, and then it would have to be, to what power is equal to b to the n. Well, of course, it would have to equal n. And then right here, the natural log of e to the n power is equal to n as well. So when the base of the log is the same as the base of the argument, the result is the exponent of the argument. The fourth property, log base b of a to the n power is equal to n times log base b of n. So basically what happens is if you have an exponent in your argument, you are allowed to take that exponent and rewrite it in front of your logarithm. And the same thing would be true working in the opposite order. So if I had, 3 log of 5, we could rewrite that as log of 5 to the third power, just kind of doing the same thing, but in opposite order. In this case, I'm taking my coefficient, whatever it is, and bringing it back in as our exponent. The same thing's true with the natural logarithm as well. The fifth property, b to the log base b of a is just equal to a, and then e to the natural log of a is just equal to a. So when a log is the exponent of a base equal to the base of the log, the result is the argument. All right, so these two sections right here is you're going to have to do this a lot. This first one is you're going to rewrite each expression as a rational number or a single logarithm of the same base. This is called condensing your logarithms into a single logarithm. One thing would have to be true to be able to condense logarithms, and that would be that the base of the logarithm really needs to be the same throughout the entire problem. So if I look at number one, log base 2, those are the same base. So if I take my argument 6 and 8/3, I'm going to multiply them because there's a plus sign in between. So we just end up with log base 2 of 6 times 8/3, which is 16. And then I can simplify this a little bit further because 2 to what power is equal to 16, and the answer is 4. Question number 2, 1/3 log base 3 of x minus 2 log base 3 of y. We really need to take the coefficients and bring them back inside the logarithm as the exponent of the argument before you start combining logarithms together. So here they brought the 1/3 inside, they brought the 2 inside. So now I have x to the 1/3 and y squared. And to be able to combine those two logarithms and condense it, the base has to be the same of the logarithm, which it is, 3 and 3. And then since there's a minus sign here, that means I'm going to divide my two arguments. And that's exactly what they did. Question number 3, working with natural logarithms, the same properties exist with regular logarithms, just the base is e. So the first part, I have x plus 2 as my argument plus the natural log of x. So I'm going to take these two arguments and I need to multiply them because there's a plus sign. X times x plus 2 would actually distribute, and I'd end up with x squared plus 2x, which is what they have. And then I would combine this logarithm and the minus the natural log of x cubed. And since there's a minus, I divide the two arguments. And they have x squared plus 2x over x cubed. And they simplified that down because every term has an x in it. So you can basically just take an x out of every single term. And you end up with x plus 2 over x squared. All right, let me erase that. Number 4, same thing. If I have coefficients out there in front, the first thing I would need to do is bring them back inside, which they did. There's only one of them right here with the 2, brought it back inside. Now we kind of just work in order from left to right. Log base 3 of x plus log base 3 of 9. I'm going to combine those by multiplying 9 and x, which is 9x. And then I would have minus log base 3 of y. Combine those by division, 9x over y. There's our answer. Then number 5 is just a little bit more of the same. I would start from left to right first. Once you bring the 1/2 in and the 2 in, we're working with natural log of x to the 1/2 minus natural log of y squared. I would need to divide those two. And then I would need to divide it by z as well. And we end up with y squared and z in the denominator and the square root of x in the numerator. So the exact opposite of that is expanding logarithms. This is when you start off with a single logarithm and you want to expand it. So kind of working through these first couple are pretty simple. Log base 3 of x times y squared. I would separate the x and the y squared with an addition sign. And then the only thing I would need to do from there is I have y squared. I would need to bring the 2 out in front. We really want our answer to be a logarithm with just a single variable as our argument, not a variable with an exponent or anything like that. So number 7, they split up the x times radical y with an addition. And then they also turned square root of y into y to the 1/2. So that way they were allowed to take that 1/2 and really bring it out front there. Number 8, they split it up first using the division. So they changed the division into a minus. And then the natural log of AB becomes natural log of A plus natural log of B. And then I have minus, and then take the 2 and bring it out front. So minus 2 natural log of C. And then number 9. Number 9 gets a little bit more complicated. And then 10's a little bit like that as well. So number 9 here, split up the division with a minus. So I end up with log of x cubed minus log of yz. That's not the difficult part of this. This is the tough part here moving forward. The minus log of yz. Notice what they did. They wrote minus, and then they split these up. It is y times z, so it needs to be a plus in between. But since there's a minus out front, you have to distribute a negative to both terms. Take the 3, bring it out front. So we ended up with 3 log of x. Negative times log of y is minus log of y. And then a negative times log of z is minus log of z. A big problem I see with kids with this type of problem is a lot of times they'll end up with a plus log of z, which would be incorrect. If it's plus log of z, that z is really going to end up in the numerator in the argument. You would not want that. Number 10 is very similar. The only difference is just kind of starting off at the very beginning. Since it's the square root of an expression, they changed it to the 1/2 power and then just took all of your powers on the inside and multiplied it by the power that's on the outside. And it's basically the same problem from there. All right, so I want to go on to the next page here. Again, trying to keep these notes a little bit shorter, get through it a little bit quicker. That way you guys don't have to spend a long time watching these videos and looking at the notes, because you guys can obviously, you can always go back and rewatch if you need to. So here, just using the inverse properties of exponential and log expressions, simplify each expression below. So this one right here, the natural log of e to the 3x, really, and you can just kind of make note of this. Anytime you have the natural log and e right next to each other, those things basically just cancel out, and you're just left with what's remaining. So in this case, I'm just left with 3x. Number 12, once again, we have natural log and e kind of attached to each other, so those would cancel out, and you're just left with x plus 2, which is left. 13, I would rewrite the cube root of e squared with a fractional exponent. The natural log and e would basically cancel out, and you're left with 2/3. Number 14, my base of the first thing they did is bring the 2 in, so it's x squared. But the base of that logarithm is 10, because it's the common logarithm. So one of your properties says that if you have a base or a logarithm in the exponent of a base, and the base of the logarithm is the same as the base of your exponential expression, that's all going to cancel out, and you're just left with the argument, which is x squared. 15 is a little bit different because they're using some properties of exponential expressions first, because I have e to the natural log of x plus 2. And if this was e to the natural log of x plus 2 written like that, then yeah, without a doubt, it's just like number 12, and your answer would be just x plus 2. In this case, it's not. So I'm going to use some properties of exponents, because I have really 2 things showing up here in our exponent. It's the natural log of x, plus 2. So one of the things we talked about at the beginning was if you have two things that have the same base, what do you do to the exponents? You add them. So you see right here the plus sign in between those two. They have now added two exponents together. So kind of working backwards off of that, I could get e to the natural log of x times e squared. Two things with the same base. Working back from here to there, I would add the exponents. I would end up with natural log of x plus 2. So then from here, e to the natural log of x, e and the natural log would cancel out, and we're just left with the x, and then times e squared, and then that is our answer. So number 16 kind of takes kind of the same logic and just rewriting that expression. So it's two expressions with the same base. 5 squared times 5 to the log base 5 of x. Those would cancel. You're just left with x. 5 squared is 25. And there's your answer. All right, so let me erase this so I can scroll down here in a second. The next thing we're going to do is talk about how to solve logarithmic equations. A little bit different than yesterday's notes because when you have multiple logarithms, you cannot rewrite your equation as an exponential function and then try to get things to be the same base. You just can't do that. So if you have multiple logarithms that are showing up in your equation, the idea is you want to really take both sides of your equation, condense it down so that way it's a single logarithm. Then hopefully the bases of those logarithms on the left and the right are equal to each other. So that way you can just really just drop the logarithms out of the equation and truly just set the arguments equal to each other. So we'll look at number 17. We'll go from there. And then note there, no solution. If the obtained value of x causes any argument of any log in the equation to be less than 0, to be a negative number, that's when it's no solution because we cannot take the log of a negative number. That was one of our key rules from the last section of notes. So number 17 here. So the goal is to rewrite both sides of your logarithm as the same, or both sides of your equation with the same logarithm. So I'm condensing logarithms. So number 17, the first thing I would need to do is bring this 2 back on the inside. So I'd end up with 2 squared, which is 4. Log of x plus log of 4. I would need to take my two arguments and multiply. So I get log of 4x. That's a single logarithm. Now it's equal to a single logarithm on the other side. Both of those logarithms has a base of 10. So for those two statements to be equal to each other, the logarithms can go away. And I just set the arguments equal to each other. 4x plus is equal to x plus 9. And I'd solve, and I get x is equal to 3. So I do need to check at this point. If I took 3 and plugged it in to any one of our logarithms, would I end up taking the log of a negative number? Log of 3, no. 3 is a positive number. Over here, when I plug in 3, 3 plus 9 is 12. That's fine. That's positive. So 3 is our answer. Number 18, the left-hand side's already written as a single logarithm. On the right-hand side, I would take the 2, bring it back in. That's 2 squared. So I have the natural log of x minus the natural log of 4. Since it's minus in between, that means I need to divide the two arguments. So here we are. Natural log of x over 4 is equal to the natural log of 2x minus 3. From here, now that I have both sides of my equation as a single logarithm with the same base, they're both natural logs, I can set the arguments equal to each other. 2x minus 3 is equal to x over 4, and then we're just solving from there. So I would have to multiply both sides by 4. That's where the 8x minus 12 comes from, is equal to x. And then we're solving, we get 12 over 7. So I would need to make sure, if we plugged in 12 over 7 into our original problem, would I be taking the logarithm of a negative number? No, I would not. So that is our answer. We're okay. All right, let me erase. We'll look at these last two, and that will be it. All right. So number 19, just really more of the same. The only thing that's happened, there's one thing that happens at the very end. So the first thing, combining these two logarithms, there's a minus in between them. So I'm going to divide the argument. So I have log base 3 of x minus 4 over 2 is equal to log base 3 of x plus 1. Same logarithm, same base, single logarithm on both sides. We can drop the logarithm out of the problem, and I'm going to set the arguments equal to each other. X minus 4 over 2 is equal to x plus 1. From here, I would need to create a proportion, and I cross multiply. 1 times x minus 4 is x minus 4. 2 times x plus 1 is 2x plus 2. And when you go through this, you end up getting x is equal to negative 6. Well, if I take negative 6 and I plug it back in, right there, negative 6 minus 4 is negative 10. That is not possible. Log base 3 of negative 10. If I try to think about that, 3 to what power is equal to a negative number? It's not, you can't do that. It's not possible. So in this case, here's one of our problems where our answer is no solution. 20, first thing I would need to do, rewrite both sides of my equation as a single logarithm. So I'd have x plus 3 and 2. Those are my two arguments on the left. Since there's a minus sign in between the two logarithms, I would need to divide. So we end up with the natural log of x plus 3 over 2. And on the right-hand side, I see a typo there because it says plus. This should be 2x plus 1 times 3. They divided those. So that is incorrect. Let me change it. So that should be the natural log. Let's see, 2x plus minus 1 times 3 would be 6x minus 3. So everything after this is wrong too then. All right, so now it's a single logarithm. They're equal to each other. I'm basically going to drop the logarithms from both sides of my equation, set the arguments equal to each other. So I have x plus 3 over 2 is equal to 6x minus 3. Create a proportion, and I'm going to cross multiply. 1 times x plus 3 is just x plus 3. And then I have 2 times 6x minus 3 would be 12x minus 6. And we're solving from there. Subtract x from both sides. I would have 11x. Add 6 to both sides is equal to 9. X is equal to 9 over 11. Okay, 9 over 11. So if I plug 9 over 11 in on both sides, let's see, 9 over 11 right there, plus 3, that's a positive, so that's good. If I plug in 9 over 11 right here, let's see here. 2 times 9 over 11 is 18 over 11. Minus 1 would be still positive, so we're good. Okay, so day 56 is the homework that goes along with this. Once you guys get done with day 55 and day 56 and you send those to me this week, really you guys are done for the week, which would take you into spring break. I am not going to post anything over spring break. Take that week and enjoy. Not doing any schoolwork. Obviously, we're going to continue on with our online stuff at least until May 1st, per the directions of Governor DeWine. So when we come back from spring break, we will continue on with logarithms, and I'll probably continue to do this. I'll probably continue to post a week's worth of lesson plans on Monday. And then that's where you guys are going to have to be working on for that week. So that way you guys can divide up your time however you guys want it to. Just so you kind of know right up front where you're going to have to be doing that week. If you ever take a 9-line class in college, it's very similar to what they do. They might say, hey, here's your lessons for 2 weeks. This is what you guys are going to have to turn in, and now just work on it whenever you need to. So just make sure that you guys are sending me emails or getting a hold of me in one way if you have any questions, and I'll get back to you. Other than that, hope you guys are staying safe, and we'll talk to you soon.